Hi, this is Miss Gonzalez again. We just got finished looking at the absolute value parent function. Now we're going to take a look at a quadratic parent function. So the quadratic is y equals x squared. And that is your parent function for the quadratic. Okay, now what does x squared mean? So you might never have heard quadratic before, but hopefully you've realized what a square is. So hopefully you are realizing x squared is the same as x times x, which is just multiplying that number by itself. So again, we're going to go look at that table of values with those 5 very special numbers. Okay, hopefully you remember what those 5 special numbers are. Okay, so -2 squared. Now, I want you to think about this. This is where a lot of people get it wrong because they like to just put it in their calculator. And if you don't put parentheses in your calculator, you will get the wrong answer. So -2 times -2, that's 2 negatives. Therefore, your answer should be positive. So a -2 times -2 is actually a positive 4. So that is going to be the point -2, 4. And we can draw our graph again. And we'll label that -1, -1, 1, and 1. Okay, so a -2 is 1, 2, 4, 1, 2, 3, 4. Okay. So now -1 squared is a -1 times a -1. So again, that should be positive. And 1 times 1 is 1. So this is -1, 1. Find this point on the graph. -1, 1 is right here. So now we have 0. What is 0 times 0? Well, it's just 0. And we put the point right here. Okay, now we have the next one. What is 1 times 1? Well, 1 times 1 is just 1. So we have the point 1, 1. That is right there. As you can see, this is turning out to be very similar to the absolute value function. So the last one is 2 times 2, which is 4. So now we find that. So how is this a little bit different? So if you remember with the absolute function, we went up kind of like a line on each side. It went up by a constant amount. It was a line. This is going up at different intervals. Therefore, I do not have a perfect line for this one. Okay, so, but it does behave very similarly. So for this one, it is good to know all quadratics are U-shaped. Our whole next unit is more about quadratics, and we will learn a whole lot more about quadratics next unit. For now, we're just going to look at how transformations change this graph and move it. So when we look at the transformations for a quadratic, it's going to look very similar as that absolute one did, except I'm going to have parentheses instead of a bracket. And I'm going to have a little 2 outside of these parentheses because I need to square what is in parentheses, and then have the plus k. So just like the absolute, my vertex, which is going to be the bottom of the U, is h comma k. Okay, axis of symmetry, we're going to label AOS, is x equals h. Everything's the same. Domain, What do you think? Do you think the domain is any different? Well, let's think about it. Domain all the way to the left, follow the arrows. All the way to the right, follow the arrows. Would be all real numbers. There is nothing x can't be here that would make this not work. So it is all real numbers. Same as the absolute. Then we look at the range. Do I have a bottom? Yep, my vertex was the bottom. And that is 0, just like before. Again, I have the bracket because I use a bracket when I am equal to something. And then I go to the top of my graph, and if I go all the way up to the top of my graph, it would be infinity. So both of these were interval notations. I did not show the set builder notation on the last one, so I'm going to show it here. You would have x such that x is in the set of all real numbers, and that would be your set notation for that. Here would be the set y such that y is greater than or equal to 0, and close that. And that is your set builder notation for the quadratic function. So this is everything I need you to know for now about the parent function quadratic. Just like the absolute value function, this is how your book looks at it. It calls the U-shaped a parabola. That is a good thing to know. Realize that the U shape is called a parabola. All quadratic functions follow the parabola. Your vertex is 0, 0. We wrote that on the other side of the parent function. This would be x equals h if we were talking about all of them. And this one opens up. You'll see next class what type of functions actually open down. But this is an example that opens up. Good luck on your work.